What if you could survive inside a star? What would it be like to exist in such an extreme environment? Imagine the searing heat, the crushing pressure, the blinding light, temperatures reaching millions of degrees, pressures so immense they can crush anything. Stars are the cosmic furnaces where elements are forged. Through nuclear fusion they create the building blocks of the universe. They are immense balls of plasma, a state of matter so hot that atoms break down into their constituent particles. This plasma is in constant motion, creating magnetic fields and solar flares. Could anything withstand such an environment? The intense radiation, the unrelenting heat, the sheer force of gravity? The answer, as you might expect, is a resounding no. No known material or life form could endure these conditions. Not for us, not for any life form we know, not for any material we've ever encountered. The forces at play inside a star are beyond anything we can currently replicate or withstand. The interior of a star is a realm of extremes that defy our everyday experience. It's a place where the laws of physics as we know them are pushed to their limits. But what if we could, for a moment, push past these limitations? What if we had the technology to explore these stellar giants up close? What if we could journey into the heart of a star and unlock its secrets? What would we find? Perhaps new elements, new forms of energy, or even answers to the mysteries of the universe. The possibilities are as vast as the stars themselves. Let's start our journey at the core, the heart of the star. Here, temperatures reach millions, even billions of degrees. The pressure is unimaginable, millions of times greater than the deepest ocean trenches on Earth. Under these conditions, matter behaves in extraordinary ways. Atoms are stripped of their electrons, forming a sea of electrically charged particles called plasma. Hydrogen atoms, the simplest and most abundant in the universe, are forced together in a process called nuclear fusion. This fusion is what powers a star. It's a continuous, self-sustaining reaction that releases an incredible amount of energy in the form of light and heat. This energy gradually makes its way to the surface of the star where it radiates out into space. A star isn't a uniform ball of fire. It's more like an onion, with distinct layers, each with its own unique properties. Above the core is the radiative zone, where energy is transported outwards by photons, particles of light, bouncing around in a chaotic dance. This process can take hundreds of thousands of years. Further out is the convective zone. Here the plasma churns and bubbles like a boiling pot, carrying energy towards the surface. Finally, we reach the photosphere, the visible surface of the star. This is what we see from Earth, a dazzling display of light and heat. Each layer plays a crucial role in the life of a star, regulating its energy output, its stability, and ultimately, its fate. So, back to our original question, could anything survive inside a star? Let's consider the most heat-resistant materials we know. Tungsten, used in light bulb filaments, can withstand temperatures up to 3,400 degrees Celsius. But inside a star, even tungsten would vaporize instantly. What about hypothetical materials? Science fiction often envisions force fields or exotic particles that could withstand extreme conditions. While these ideas are intriguing, they remain purely theoretical. The reality is that the interior of a star is simply too hostile for any known form of matter to survive. The temperatures, the pressures, the radiation, it's a recipe for instant annihilation. Section 5. The limits of technology. Even if we could shield ourselves from the heat and pressure, there are other challenges. The radiation inside a star is intense, a barrage of high-energy particles that would be lethal to any living organism. And let's not forget the gravity. The gravitational pull of a star is immense, strong enough to crush anything that ventures too close. So, for now, journeying into the heart of a star remains firmly in the realm of science fiction. Our technology, impressive as it may be, is nowhere near capable of withstanding such an extreme environment. Section 6. The Dance of Atoms. In the heart of the cosmos, a mesmerizing ballet unfolds, one that has been ongoing for billions of years. But even though we can't physically explore the inside of a star, we can study it from afar. With the help of advanced telescopes and observatories, we peer into the night sky, capturing the faint whispers of light that travel across the vast expanse of space. By analyzing the light emitted by stars, we can decipher their chemical composition, their temperature, their age, and even their motion through space. This light, broken down into its spectrum, reveals secrets hidden within the stellar glow. We know, for instance, that stars are mostly hydrogen and helium, the primordial elements birthed in the aftermath of the Big Bang. These two lightest elements in the universe are the fundamental building blocks of stars. These elements are constantly fusing at the core, under immense pressure and temperature, creating a furnace of nuclear reactions. Creating heavier elements like carbon, which is essential for life as we know it, oxygen, which we breathe, and iron, which forms the core of our planet. In a sense, stars are the alchemists of the cosmos, transforming simple elements into more complex ones through the process of nuclear fusion. This cosmic alchemy is what drives the evolution of the universe, creating the diversity of elements that make up everything we see around us. And when stars die, they spew these elements out into space, enriching the interstellar medium with the building blocks of new stars, planets, and even life itself. This cycle of birth, death, and rebirth is the grand dance of atoms, a continuous process that has shaped the cosmos for billions of years and will continue to do so for eons to come. Section 7. Stellar Nurseries, where stars are born. Stars are born in vast clouds of gas and dust called nebulae. These clouds, often spanning hundreds of light years, are cold and dark, but within them, gravity is at work, pulling matter together. As these clouds collapse, they heat up and eventually the core reaches a temperature high enough to ignite nuclear fusion. A star is born. This process, from collapsing cloud to shining star, can take millions of years. Section 8. The life cycle of a star, from birth to afterlife. Stars like us have a life cycle. They are born, they live, and they die. The length of a star's life and the manner of its death depend on its mass. Massive stars burn brightly and die young, often in spectacular supernova explosions. These explosions are some of the most energetic events in the universe, outshining entire galaxies for a brief period. Smaller stars like our Sun live much longer, billions of years, and end their lives more peacefully, gradually fading away as white dwarfs. Section 9. Beyond our Sun, a universe of stars. Our Sun is just one of billions of stars in the Milky Way galaxy, each with its own unique characteristics. And the Milky Way is just one of billions of galaxies in the observable universe, each teeming with countless stars. Each star is a unique cosmic engine, fusing elements and radiating energy into the vastness of space. Some stars are solitary wanderers, while others exist in binary systems, two stars locked in a gravitational dance orbiting each other. There are red giants, supergiants, neutron stars, pulsars, a whole menagerie of stellar objects, each with its own fascinating story to tell, waiting to be discovered. Section 10. The search for exoplanets, seeking life beyond our solar system. In recent decades, astronomers have discovered thousands of planets orbiting other stars, called exoplanets. Some of these planets are similar in size and mass to Earth, and some orbit within their star's habitable zone, where conditions might be right for liquid water, and perhaps even life, to exist. The search for life beyond Earth is one of the most compelling quests in modern science. And while we haven't found definitive evidence of extraterrestrial life yet, the sheer number of stars and planets in the universe suggests that we are not alone. Section 11. Our place in the cosmos. As we explore the universe and ponder the possibility of life beyond Earth, it's humbling to consider our place in the grand scheme of things. The cosmos is vast, stretching beyond our wildest imaginations, filled with countless stars, planets, and galaxies. Each one holds the potential for new discoveries and insights. We are but a small species on a small planet, orbiting an average star in a vast and ancient universe. Our Sun is just one of billions in the Milky Way galaxy alone, and our galaxy is just one of billions in the observable universe. This perspective can be both humbling and awe-inspiring. Yet, we are capable of asking profound questions about the cosmos, about our origins, and about our place in the universe. These questions drive our curiosity and fuel our desire to explore. Through the lens of a telescope, we peer into the depths of space, seeking to understand the fundamental nature of reality. And in seeking answers to these questions, we push the boundaries of human knowledge and expand our understanding of the universe and ourselves. Every discovery, no matter how small, adds to the tapestry of our collective knowledge. From the tiniest particles to the largest cosmic structures, each piece of information helps us build a more complete picture of the universe. The universe is a place of wonder, of mystery, and of endless possibilities. It challenges us to think beyond our everyday experiences and to consider the infinite. The beauty of distant galaxies, the enigmatic nature of black holes, and the birth of stars all remind us of the complexity and grandeur of the cosmos. And while we may never be able to journey into the heart of a star, we can continue to explore it from afar, unraveling its secrets and marveling at its beauty. Through the advancements in technology and science, we can simulate and study these celestial phenomena, bringing us closer to understanding the universe's most profound mysteries. Our quest for knowledge is unending, and the cosmos will always be a source of inspiration and wonder.